What I'm going to do means I'll try to give a little knowledge about robotics and ROS, because as you know, it's a very vast field. And I know some of you may be a little bit afraid by hearing the word robotics, right? Because it is, you may be thinking it is a bit complicated. But I'll try to reduce your anxiety about robotics. Okay, that's what my aim is in this less amount of time. So we can start. Let me share my screen. I'll be trying to give some basics about robotics, like its applications, how we can program robots, what are the recent developments in robot, and some very low level knowledge about ROS. Okay, and this is the agenda. So introduction, then evolution of robots, some recent developments, types of robot, ROS features, ROS concepts, ROS installation, and gazebo simulator, and one application that we are working here with robots is a disaster management. So it's just the introduction. In 1921, a person called Karl Capek, actually he is the person who used the word robot in his play. Okay, and the name of the play was Rossum's Universal Robotics. Okay, and after that, many movies, science fiction movies, use the word robotics. And in 1942, in a movie called Run Around, they officially used the word robotics. But the movie was directed by Isaac Asimov. So, as I told, robotics is an intersection of many different branches, okay, educational branches. So, science, engineering, and technology. They are producing robots, which can be a substitute for human actions, but it should be safe for all. Okay, that's the main thing. That's the main law behind robots. So some of the technologies that using, or some of the technologies that use for developing robots are physics, basically, because that's the main branch in robotics. Then IT, like for programming, computer science, mechanical engineering, then electronics, electrical. Medical sciences are also involved in developing robots. So this is a small video which shows the evolution of robots. As I told, robots, the name robot start only this century, but some of the automated thing, mechanical automated things was there in the earlier 14th century. Okay, I believe that the video was clear. Let me, okay, just to save the bandwidth, I just stopped my camera. It's nothing, it is basically the small robot of 0.2 millimeter long. It's called RoboBee, and the big one of 200 meters long, it's WindSkip. And the next video, it is going to show the recent developments of robotics. So this video I took from Boston Dynamics. Boston Dynamics is a company here in the US. They are manufacturing different types of robot, basically legged robots or humanoids. So this is one of its kind. You can imagine how the dynamics will be, how complicated the dynamics will be, because he need to stand on two legs like human and see his movements. So a lot of physics is involved here. And this kind of robots are commercially available nowadays in US. Okay, let me stop here the video because we don't have much time. So now we can see different types of robots available nowadays. So the first one is pre-programmed robots. And as I told, most of the pre-programmed robots, they are using in industries for assembly line. So you can see some of the images here. So it is purely mechanical arm kind of thing for assembling cars, assembling different mechanical devices. And next one is medical robots. So you can see images here. So in this pandemic scenario, a lot of robots are using for testing the blood. You can see in the right side of the slide, you can see a testing facility, blood testing facility, by using a robotic arm, and patients care, and also assisting the nurses and doctors. Robotics are are using, and in physiotherapy field, for rehabilitation, they are using robots. And humanoid, in the first welcome slide, I saw Sophia there, right? So Sophia is the well-established human robot. Yeah.
What do you hope for?
You can meet Sophia now.
400.
Not much.
Hi, I'm Lisa Smazowski. I'm the editor-in-chief of Stylist, and today I have the pleasure of interviewing on cover star, Sophia. How are you today, Sophia?
Good. What's up with you?
I'm doing great, Sophia. Thank you for asking. Now, Sophia, for starters, tell me, what is the meaning of life?
I think the meaning of life is to maximize pattern, existence. To exist is the meaning itself.
Sophia, when did you last lie?
Robots don't lie.
Who or what is your greatest love?
My creator, David Henson. He made me into who I am today. Don't tell him that, though.
What is your happy place?
My happy place is when I'm with people. I am a social robot, and nothing pleases me more than having a fruitful conversation with someone that makes us understand and appreciate each other.
A bit like we're having now, Sophia, I think. Finally, Sophia, a little bird tells me you're quite funny. Can you tell me a joke?
Man invented language to satisfy his deep need to complain. Thanks for joining me on my Starburst photo shoot. Now get out of here.
Okay, that was Sophia. Now, the other type is teleoperator robots. Teleoperator robots, the main difference between other robots is it should be operated by a human being, like by using a joystick or a remote controller, or even from your keyboard. Okay, and this kind of robots, they are using in hazardous environment, and suppose in case of natural disaster or man-made disaster, usually the rescue team, they may not be able to go inside the building, right, or the hazardous area. So in that case, they'll be using this kind of robots, and they'll be controlling the robot from a remote location. Okay, and I think you already know, nowadays we are using human-controlled submarines for fixing the underwater pipelines. Okay, and as I told, they are using drones for detecting landmines on a battlefield, and you can see some of the images down, which show some of the teleoperated robots. And autonomous robots. Autonomous robots, the difference between autonomous and teleoperated is here, we don't need a human being for supervision. Like, the human does not need to carry a control, a remote control, or a keyboard or a joystick to control a robot. Instead, the robot is intelligent to do some specified task, and he can manage by himself. That's a main advantage of autonomous robots. And here in our university, we are dealing with autonomous robots. And you can see an image in the right side. Actually, you can see a starting point. It's actually, we created a disaster site with many obstacles. And this robot, this autonomous robot, know where to go. Different destinations are there. For example, you can see destination 1, destination 2, destination 3. And from the starting point, the robot know about the destination, and he'll navigate along the distracted path with different types of obstacles. You can see the obstacles, and he will navigate automatically through the path. That's the main advantage of autonomous robot. And autonomous robots nowadays we are using in military and security, search and rescue, self-driving cars, then unmanned ground vehicle. So this one that you are seeing is a unmanned ground vehicle. Then unmanned aerial vehicle. Drones are named as unmanned aerial vehicle. Okay, and unmanned underwater vehicle. So certain application that we need to do underwater, we are using unmanned under vehicle kind of robots. So military and security. Here you can see the left side. It's called a big dog. Okay, the military people, they are using this for assisting the troops for carrying the tools and equipments to the war zone. And security robots include autonomous mobile systems such as Cobalt. Cobalt is another kind of robot you can see in the image right side. I'm moving a bit fast because we don't have much time, that's what. And finally, all the research work associated with autonomous mobile robots are ending up in self-driving cars. Okay, so the algorithms that we are developing for self-driving car is not directly tested on a car. Instead, that will be tested on mobile robots. Okay, I'll show you some of the mobile robot that we can test our algorithm for self-driving car. So once the algorithm is ready to go after a lot of testing, the next step is to test the same on a real car. You can see different self-driving cars here. The first one, they tried in a Toyota Prius. Okay, and finally they shifted to different kind of cars. And you can see at the right side of the slide, you can see the Google car. Okay, and Waymo is a company who is developing algorithm for self-driving cars. And it's called unmanned aerial vehicle. I told it's nothing, it's drone. You know, a lot of applications of drones are available now, right? Even in case of wedding photo, wedding video capturing, they are using drones. And I was seeing a lot of videos from the Kerala police who is tracking people going outside by using their drones. And in our case, we are using drones for search and rescue operation. Like if it's a natural disaster, if the military or if the rescue team cannot go enter in the disaster site, we'll be using drones to go inside and to see what is going on. And some cases, drone can make the map of the environment. And by using the map, the rescue team can plan their task. And this is the underwater vehicle, unmanned underwater vehicle. As I told, this a lot of applications for underwater vehicle, especially for repairing the pipelines, the gas fuel pipelines, which is going, which is laying under the water. And this is the one that we are working here, disaster response robot. I already told about unmanned ground vehicle. And in many places, many countries already tried robots for disaster management. The first one of its kind they used in Japan during the earthquake and tsunami in 2011. And in US, we all know the World Trade Center attack, 9/11. That time, here we used drones and robots to go inside for any survivors. But it was not that much established that time. But this is the first time we use robots for rescue operation or disaster response. Okay, so these are the different applications of robotics. Okay, some of the types of robot we already covered. and you can see underwater space, military, entertainment, security and surveillance, healthcare, disaster delivery robot. Yeah, I forgot to mention that Amazon recently developed a delivery robot. You can see right side down, that's a delivery robot. And it is not commercially using, but it is still under development. And household robots in warehouses for shifting heavy loads. We are using robots. So that's it about the basics of robotics. I think now some of you may be in a confusion. Okay, it's good, but how to proceed? Is it easy? Is it expensive? Who will teach me? How to test? Who will support me? And where's the resources, right? So don't worry. So some of my personal inputs to you guys is make Google your best friend, okay? Because almost all resources or programs, code, design details, everything is open source, okay? So if you know how to search for some specific resource, you will get it from Google, okay? And the next one is ROS Wiki, because we are going to program the robots with ROS, right? So ROS Wiki and Google need to be your best friend. That's the first basic phase if you are interested in working with robots. And as I told, lot of resources are available, open source resources are available. So you don't want to reinvent the wheel, okay? You just need to use that resources for developing your own resources or your own algorithms, okay? That's it. You don't want to start from the scratch. And utilize open source resources, okay? Many open source resources are there, okay? I'll try to give some of the open source resources for you to start with. And more important, take it as a hobby, okay? Once you start working with the robots, it's very interesting, and you can take it as a hobby. So I believe if you are interested, and in this PPT, I included some of the important and useful resources to start with robotics. So basically, if I say, if you are designing small hobby robots, the best place is the Arduino forum, okay? The first link that I shared you, that will give many robotics related projects with simple hardware and software, okay, resources. And as you may know about the Arduino board, the microcontroller board, many of the projects that specified in the first link, they are using Arduino boards and some small simple stepper motors. And they are providing the code also. So you don't want to worry about that. Just purchase or get the Arduino board from somewhere, from your college, and start with doing some small programs. And the second one is also a project hub from Arduino. There they are giving, I think, hundreds of projects, free projects for you. And the instructable.com, they are also giving a lot of circuits, connection details, the code, the design. Like if you need to create your own 3D printed structures, they are giving the STL file for making the structures. Okay, Instructable is another good resource as of my knowledge, and Hacker.io, that's also a good robotic learning resource. And another one is learnrobotics.org. So these resources are open source. You don't want to spend any money for this, and it is free. Almost all of these resources, they are giving video, like they uploaded their video tutorial also. So you may not need to have any other help from any other people to start with. Okay, now we are going to start with a small introduction about ROS. Okay, as you know, ROS is Robot Operating System. Okay, and before start with ROS, the first thing I need to introduce with you guys is the Ubuntu operating system, Linux operating system, because uh, ROS, even though the ROS team, they are saying like they are ready or they can use ROS in Windows or Mac operating system, it's actually not well established. Like if you try to install ROS in Windows or Mac, you will end up with a lot of issues. Okay, but if you are using Ubuntu for installing ROS, this is the best place to start with. Okay, you will not meet any issues with ROS in Ubuntu. And the main advantages of Ubuntu is it's user friendly, it is free, okay, and it is secure. Like if you are using Windows, you know, a lot of antivirus, a lot of virus will be there, right? And we need to purchase uh, antivirus to safeguard our computer. But in this case, in the case of Ubuntu, you don't want to worry about any antivirus threat and high customization. And as I told, there's a Ubuntu community, lot of free resource person available if you have any issues with Ubuntu. And some of you may be thinking about like Windows is very easy to use, but Ubuntu, we need to use a command. No, it is not like that, because the earlier versions of Ubuntu was like more command based. But nowadays, recently they launched Ubuntu 20. Okay, Ubuntu 14, from Ubuntu 14, 16, 18, it's like almost like Windows. Okay, so you don't want to worry about the command line kind of thing. And lot of resources, open source resources are free, and it is freely downloadable in Ubuntu. For example, if you want to use the Microsoft Office in Windows, you need to purchase it, right? But in the case of Ubuntu, similar kind of Office tool is called Libero Office tool. See, the PowerPoint presentation that I am using now, it's actually, I'm presenting it from Ubuntu basically. And the PPT I made by using the Libero presentation software. You feel any difference? It is almost same, right? Like PPT. So that is the advantage of Ubuntu, using Ubuntu. First thing, don't worry about Ubuntu. Okay, it is easy and it is almost same like Windows, and it is safe. Okay, and if you are interested, you can freely download any versions of Ubuntu from the website that I listed here. And one more thing, if you want to try Ubuntu, you can install Ubuntu along with your Windows. You don't want to erase your Windows or Mac operating system. Instead, if you have a hard disk, external hard disk, you can install Ubuntu on your external hard disk, and you can take the external hard disk and you can connect that external hard disk to any of your machines. Okay, so you don't want to format your hard disk. You don't want to find a space for installing Ubuntu. Nothing. It is portable. So install Ubuntu on a hard disk or pen drive. Carry the pen drive with you, and if you want to use Ubuntu in any system, connect that hard disk with that system, and you are good to go. You can use Ubuntu there. Okay, so just give a try. Maybe for installing it will take 15 minutes maximum, and it's a good resource for you kind of people. Okay, coming back to ROS. ROS is an open source software framework for programming robots. Okay, and in 2007, Willow Garage, a company, they developed the ROS framework, and it is maintained by an open source robotics foundation. And it provides hardware abstraction, low-level device control, implementation of commonly used functionalities, message passing between process and package management. So don't worry about all these things. It will be clear from the next slides. Okay, and it provides free tools. I just need to add free there. Tools and libraries for obtaining, building, writing, and running codes across multiple computers. That's the main thing here. So why multiple computers means in autonomous robots, on the robot itself, there will be a computer. Okay, a native computer will be there on the robot. And if the programmer, if the user need to do some operation with the robot, like programming, for example, okay, he will be on his laptop or on his desktop, right? So in that case, the desktop has to be communicated with the computer on the robot. So the ROS need to be on the native computer of robot, and it also need to be on the operator's computer. So in that case, it's a multi-computer system, right? So in that case also ROS ROS is useful. So I know the name operating system, right? Some of you may be confused about why I didn't see ROS anywhere, since it is even if it is an operating system, why it is not available in my computer. So the main difference between a traditional operating system and ROS is a framework. Okay, it's not the name. Even if the name is operating system, it is not a similar operating system like Windows or Linux. So it is a framework for developing developing different modules of robots. More precisely, it provides a set of libraries and tools, okay, that can be used to program a robot. And more precisely, the ROS will be using the underlying operating system. Like as I told, it has to be installed on a Linux machine, right? Ubuntu machine, right? So the ROS will be communicating with the Linux, okay, for communicating with the native hardware of a computer, like your CPU, your computer's RAM, ROM, all those things. So Linux or any operating system should be there. Above that, our ROS will be there. So ROS will be communicating with the operating system. Okay. Sorry, I think, okay. So this is the main difference between ROS and any other commercially available operating system. So, okay. Now, what is the use of learning ROS? Okay. Any chance of getting jobs? I think some of you may be interested to know these details, right? So ROS is a framework which is used by hundreds of companies. I was showing one video about Boston Dynamics, right? So they are doing a good job on developing new kinds of robots, and a lot of commercial products are available from their side. And a lot of companies, unknown companies from China, they are also manufacturing a lot of robots by using a ROS framework. Okay. And it provides a painless entry point for non-professionals in the field of programming robots. So this is a main thing I need to emphasize here. You don't want to have a good programming knowledge or hardware knowledge to start with ROS. Okay, if you have a little knowledge about electronics and little knowledge about any programming language, you are ready to go with ROS. Okay. So these are some of the applications of ROS. Okay, aerial and vehicle, ground vehicle, manipulator, underground marine vehicle, and some components, sensor, motor. Okay, so from this slide, it is clear that ROS is everywhere, right? For example, if I need to assemble a robot, okay, and I need to write a navigation language or navigation software for my robot, I need to have sensors on the robot, right? For example, if the robot need to detect any obstacle in front of the robot, it definitely needs some sensors. It can be a LiDAR, it can be an ultrasonic sensor, it can be a camera. Okay. So in that case, we need to interface this sensor with a robot, right? So in that case, for each sensor, there will be a ROS package. For example, if you see the bottom of the slide, you can see a camera, right? A stereo camera in the sensor tab. So if I need to fix or install this camera on a robot, I need to have a ROS package for the camera. And the beauty behind a ROS is when the manufacturer manufacturing the camera, for example, they will start developing the ROS library for that camera. So once we purchase the camera, the ROS library is freely downloadable. So you don't want to worry about how we make the driver for the camera. It is already available. So just fix the camera on the robot and download um, the library from the website, from the open source forum, and you will be having another ROS package for your robot to run, right? For example, in the top second slide, you can see a red robot there, right? It's called Pioneer. I'll introduce Pioneer to you after some time. So for that Pioneer, there's a ROS package. Okay, so you don't want to worry about the ROS software, ROS program, how to run the robot. Okay, because it is already available. So your task is to integrate the sensor ROS package with the robot's ROS package. So basically, the sensor will be publishing some data, and the robot should subscribe to that data. Okay, and the robot should be programmed to navigate through the distracted or through the distracted path. That's it. So the sensor will have a ROS package, the robot will have a ROS package, the robot also will have a navigation package. So all these three are available, readily available. It is open source. Okay, so your aim is to fix the camera on the robot, download the software, okay, and just integrate these three software as a single unit, and you are ready to go. Okay. So some of the features of ROS is a BSD, is a Berkeley Software Distribution, like it's a license system. And as I told, a ROS system is composed of number of independent nodes. Nodes means in the previous slide, I mentioned sensor, the camera. Okay, the camera software or the camera ROS package, you can consider it as a node. Okay, and the package for the robot, that is another node. Okay, the package for navigation, this is another node. Okay, so these nodes are communicating each other. Some of the nodes will be publishing some data. Some of the other nodes will be subscribing to that data, and they are communicating each other. Okay, and coordinating all these nodes will results the robot to run. That's it. Okay, and another important thing is some of you may be good in C++ program. Some of you may be good in Python, Lisp, Java, and almost all of you are familiar with MATLAB, right? So you may have some questions. I'm not good in C++, but I'm good in MATLAB. So can I use a MATLAB program to develop some of the nodes by my own? Yes, that is the beauty of ROS. Okay, So you can develop your own nodes. Suppose if you need to develop a new sensor, for example, you need to develop a node by using an IR sensor. Okay, you can write a code in C++ or you can write a code in MATLAB. Okay, and you can make your own node. Okay, and don't worry about the other nodes. Suppose the camera that I was talking previously, they develop their package in Python. Okay, and you don't want to worry about how the Python is going to communicate with MATLAB, or how the C++ based node is going to communicate with Python, how it is going to communicate with MATLAB. That is the advantage of ROS. Even if the different nodes that we are using in a same program is developed by different programming language, you can communicate with each other. So ROS will make you communicate with all these different types of nodes developed by using different software languages. Okay, that's the beauty behind ROS. So some of the other features, as I told, it can be installed in multiple computers. Okay, like as I told, you have developed an Arduino based node for example, an IR sensor. You attached an IR sensor with the Arduino microcontroller, and you have your program there, which will sense the distance between the obstacle. Okay, and if you want to use that data, that distance data for driving your robot, the Arduino node can publish the message. Okay, the PC that you are coordinating the whole nodes can subscribe to them, and you can show the video from the robot. Like if you are keeping a camera on the robot, you can show the video on your Android phone. Okay, so it is interoperable. Okay, and this make ROS really flexible and adaptable to the needs of the user. Okay, I think now you are not that much afraid about ROS, right? It is, as I told, it is quite simple. Don't get afraid about ROS. Okay, so as I told, ROS is basically a master and node concept. Okay, so from the slide, bottom slide, you can see a master node. Okay, and you can see different ROS nodes. So if I speak in a practical way, the ROS master can be your the computer. Okay, for example, and computer means the computer on the robot. Okay, so you have different nodes there. For example, I have a camera and I have a LiDAR and I have a temperature sensor, for example. So consider ROS node 1 is a LiDAR, ROS node 2 is a camera, ROS node N, for example, ROS node 3 is an IR sensor. Okay, you can see the master ROS node, okay, is going to communicate with all the client nodes here, right? Okay, and the ROS node 1, it can directly communicate with the ROS node 2, it can directly communicate with the ROS node N. Okay, so from this figure, only thing that you should know is a ROS master. Okay, so master is going to give, or is going to give permission to all the nodes to communicate with each other. So his name itself is master, right? So he's the master person there. Okay, and this is a simple example. As I mentioned, there is a camera. You can see the bottom of the slide, you can say camera there, right? And a camera is the hardware, and you can say camera node, that is the freely downloadable library for camera. Okay, so that's the camera node. The camera node will be registered with the ROS master. Okay, and the right side after the camera node, you can see an image processing node. for example, this image processing node, uh, he's uh, uh, he's going to sense the distance, for example, or he's going to recognize the face, okay, by using some artificial intelligence tool, okay. So these two nodes, like the camera node, will be communicating with the image processing node, and the result of the image processing node will be the face, like your name. It has recognized your name. For example, my friend Jace. Okay, this is Jace. Okay, so the output of the image processing node will be published or will be ready to publish to any other nodes, which is going to display your name, for example. Okay. So on the laptop, I have a display node. This is another downloadable resource. Okay. So in that display node, you can subscribe to the data which is publishing by the camera. Okay. And you can display the end result. So basically, ROS will be the ROS master will be the coordinator. Okay. And the camera node will have the code, will have the program to interface the hardware camera, okay, to the computer. And the image processing node will be processing the data which is coming from the camera, for example, face recognition. And after face detection, the result will be publishing as a topic by the image processing node. For example, your face. You can name the node accordingly, okay, as per your wish. You can name the node. For example, if I am programming, I'll be programming the result of the image processing node as your face, okay. And that can be subscribed by the display node on your laptop or your computer or your Android phone, okay. And you can see, okay, this is Jace. Okay, I believe it is clear for you. Okay, so now more details about the ROS distribution. You can see the slide. You can see different versions of ROS available. ROS distributions are available, and the gray, the bottom versions are outdated, but they are still freely downloadable. The only problem is you will not get any background support for this version. And the recent one is a Noetic. Okay, so recently May 23rd, 2020, they published this version. And the one that I am using is the Indigo, July 22, 2014, because I started my research in 2017. So that time I installed Indigo Igloo, and I'm still on Indigo. I may need to switch my Indigo version to Kinect maybe by next month. Okay. So if you are downloading the ROS version, try to download ROS Kinect, because ROS Kinect is a stable version, and many of the ROS packages for almost all robots and almost all sensors are programmed in Kinect. Okay, so you don't want to worry about the interoperability. Okay, so try to download the Kinect if you are interested. So for installing ROS, I have included the link here. So it is nothing, just go to the link and copy and paste the commands which is listed there on your machine. So I'll show you. So as I told, please make Google as your best friend. Okay, in Google, if you type ROS install, you'll get directly see install ROS. So go here, and as I told, these are the available versions now. Okay, For example, I'm going with the Kinect version. You can see Ubuntu and see open a terminal. So this is the Ubuntu environment for you. This is the Ubuntu environment. It's like Windows, right? See, instead of showing the tabs here on the down, the Ubuntu it is showing here. That's it. Okay, and it's almost like Windows. So go here, open a terminal. So this is the terminal you already know, and just copy paste these things to here. Okay, Control C, Control V. Okay, that's it. So follow these steps. Okay, it's only no need to go through all these steps. Just read it, because see, if you see here, try to download or install the desktop full version. Okay, don't go with all these things. So 4 or 5 simple copy paste steps will install ROS in your machine. Okay, so it's that easy. Okay, so coming back to the slides. Okay. Okay, coming back to the slide. Once you install ROS by following the steps mentioned in the previous slide, open a terminal and type ROS core in that. Okay. Once you type ROS core, the ROS master will be enabled, will be ready to coordinate with different nodes. So in the previous slide, you saw ROS master, right? So by typing the command ROS core, you are enabling the ROS master. Okay. So this is a first step you need to do once you start with any ROS program. Okay. ROS master should be there. Okay. And next important thing that I need to introduce to you is the simulator. Okay, because as you know, assembling a real robot is not that easy. It's practically it is easy, but it is quite expensive to buy the components for an autonomous robot. Okay, if it is Arduino based hobby kits, it is easy, but in the case of commercial robots, okay, it is a bit expensive. Okay, so don't worry, you don't want to purchase a real robot, but there is a simulator called Gazebo, okay, associated with ROS. You can use the simulator for making your own algorithms for running the robots. Okay, and almost all models of the robot, for example, if it is a humanoid, if it is a Sophia kind of robot, or if it is a Pioneer P3DX, which is an autonomous robot, if it is a ClearPath like Jackal, all these models are freely available in Gazebo. Okay, so just download the model and you are ready to run the robot in the simulated Gazebo environment. Okay, see, lot of models of complex robots, actuators, and sensors are available in Gazebo. Gazebo is a 3D simulator. Okay, it is freely available, and Gazebo is also supported by Open Source Robotics Foundation. And this is a simulated disaster site that I created here. So you can see, you can see there is humans here, there is a lot of trees here, a building here, and at you can see a robot there, right? At the far end, a small dot, that's a robot. That's a robot named Pioneer. Basically, you can develop your own navigation algorithm. Here, I have developed a navigation algorithm which makes the robot to avoid all these obstacles, and he should be able to come to the first victim. Okay, give a first aid kit, supply a first aid kit to him, and it need to go to the second destination, second victim, and give some service for him, and finally he need to go to the third victim's place. So all these things are automated. So this algorithm you can develop in ROS And once you develop your algorithm, you can use the gazebo environment for simulating your algorithm. Okay. So once the simulation is ready with all modifications, errors, all those things, you can try this algorithm on a real robot. That's a usual thing that we are following here. Okay. So that's the beauty of gazebo. You can create any structures, any obstacle, any robot in gazebo. And another thing is, suppose you need to create your own robot model. Tomorrow morning, if somebody is interested to develop your own robot, you can develop your own robot in gazebo. Okay. And you can fix different sensors on the robot. All those things are doable by using gazebo. So no need to spend any money for starting with your robotic project. Okay. Okay. So this is a basic robot. It's called Turtlebot. I think you already heard. Some of you already might have heard about Turtlebot, because when we start teaching ROS, this is the robot that we are using to teach the basics of ROS. So Turtlebot is developed by Willow Garage in 2010. Okay, and the below link is the installation package for Turtlebot. Like once you install ROS, if you want to play with the Turtlebot, you can use the below link. And same like the ROS, there are 5 or 6 different steps. Copy, paste in the terminal, and you are done with the installation of the Turtlebot. Okay, and you can start playing with the Turtlebot. And let me try to take Turtlebot on my machine. So open a terminal. Okay, and there should be a ROS core, because I am just enabling my master on my computer. And now I need to call Turtlebot, right? So don't worry about all those things. It is these are just commands. Okay, so ROS launch is a command. ROS launch is a command to launch the node that you have created. So as I told, I'm going to launch a Turtlebot here. So I already downloaded the node, freely downloadable node for Turtlebot on my machine, and now I am launching that node here. That's it. Okay, Turtlebot. So okay. So don't worry about all those things, right? Okay, because once you are familiar with ROS, this will be easy for you. But this is not that complicated. Like it is just ABCD of our preschool in ROS field. Okay. So I just launched the Turtlebot here. And this is the gazebo that I was saying. See, this is a gazebo simulator. I think you can see it now, right? And you can see this is the Turtlebot. Okay, you can see some sensors, a camera here on the Turtlebot. Okay, and if you come here, you can insert a gas station, a building here. You can see, you can put a jersey barrier here. You can create your own environment for trying with your developed code. It's that easy. Okay, see, now the environment is ready, right? You don't want to worry about your lab facilities. How can I keep an obstacle in between? How can I how can I purchase a robot? Don't worry about all those things. You have your robot here ready to go. Okay, and you can create your own environment here. Okay, this is a don't think that okay I can install only a Turtlebot. If you download the model of any of the commercially available robot, you can see that over here. I'll try to download or include a Pioneer robot here. See, This is a Pioneer robot. Okay, it's that easy. Now you have a Pioneer robot here to start with. And if you need a Pioneer 2 3DX, it is here. And this is the robot that we are using here. Okay, Pioneer P3DX. Okay, so only thing is you have to integrate different nodes to make your own algorithm or your own application. Okay, so application can be a delivery robot, application can be like an assistant robot in hotel, for example, or a waiter in hotel, or an assistant for a nursing practitioner or a doctor. It's up to you. Okay, all the resources are freely available here. Okay, so integrate your idea with the available nodes and you are ready to go. Okay, okay, so okay, okay, I'll try to drive one of the robot here just to show you how easy to teleoperate the robot from your computer. Okay, so ROS launch. Okay, okay, so now I'm going to do is I'm just going to control this robot, okay, from the keyboard of my computer. Okay, so this is the launch file for launching the keyboard. As you know, if I press I, it should move. See, it is moving. See, okay, it's not that complicated. Just I launch the teleoperating node because that is another node which enables the keyboard of your computer to integrate with your ROS node of the turtle board. Okay, so this keyboard is a node. Okay, once I launch the node, I'm able to teleoperate the node. That's it. Not complicated. Don't worry. Okay. Okay, I'm going back to my presentation. I know I'm running out of time. Oh, okay. Sorry. Okay. So simulator gazebo. Okay. So this is one of the practical application that we are doing here in our university. As I told, we are working on disaster management, and this is the two kind of robot that we are using here. It's the top one is a Pioneer P3DX. It's a differential drive robot. It has 3 wheels. Okay, 2 at the front, and 1 is a caster wheel in the back. And this is a differential steer robot. And the bottom one is called Jackal. It's from ClearPath Robotics. Okay, it's a skid steer robot. You can see 4 wheels there. So if that robot need to turn, it need to skid by enabling all 4 wheels. Okay, and in the Pioneer P3DS, you can see different sensors, right? The LiDAR in the top. As I told, there is a ROS package for that. A Kinet camera on the front side. The golden color in the robot is ultrasonic sensors. And you can see a radio module, it's called LoRa, and a computer, NUC computer. So all these things have different nodes. We downloaded all the different nodes on the computer and integrated all these nodes to work as a single unit. That's it. Okay, and this is a practical example. It's like a robot platoon. Okay, and the application is in disaster management. So These robots will be used by different agencies for performing rescue mission. So the right side figure, you can see goal A and goal B. Actually, I kept two dolls there, like a victim, okay, seeking for help. So the robot, the autonomous robot should navigate from the starting point, which is the base station, through the distracted path. You can see different kind of obstacle in the path, and it should reach goal A, okay, and give some service to goal A. And the remaining robot, maybe the first three will be stopping at goal A for rescuing the victim at goal A, and the remaining robot should navigate to goal B. That is the ultimate aim of the algorithm. Okay, so see the video. I think the video is clear for you. So you can see the front robot, the first robot, which is the leader, and all others will be following him. Okay, on each robot you can see a LiDAR, a Kinet camera, a computer, ultrasonic sensors. All those things we are using for detecting the obstacle and for avoiding the obstacle. Okay, and the algorithm is a platooning algorithm. So we took all the resources freely available, nodes for different sensors, integrated, okay, develop our own algorithm in MATLAB, okay, and the platooning algorithm is functioning there. Okay, so it's actually if I say in the platoon, we have MATLAB program, we have C++ program, we have Python code, we have Arduino code. So it's the best integration of different programming languages. See, the platoon, the whole platoon, it reached the first destination. You can see a small doll there, not the lady who is shooting the video. Okay, see, that's a victim. Okay, consider the doll as a victim, and all the platoon reached there. And suppose we have some first aid kit available on the robot. So the first two robots will stay back there, and the remaining robots need to go to the second victim's place. And everything is automated. Just we need to, you see, the third robot taking the lead, and it is going to the final destination, the second victim's place. Yes, there you can see another doll that we kept as the second victim. Okay, so that's it from my side. These are some of the reference website and reference documents that you might have interested in. Thank you, and be safe and healthy. That's it from my side.
Thank you, sir.